Hello, everyone. We're going to get started with our webinar on open source visualization and data analysis in the browser. My name is Lisa Avila, and I'm one of the founders and the CEO of Kitware. I'll be speaking with you for just a few minutes right now while we welcome everybody and let everybody have a chance to join the webinar and get settled. After that, I will pass things over to Sankhesh Jhaveri, who is a principal engineer on our scientific computing team here at Kitware. Sankhesh is going to give you an overview of the visualization toolkit, also known as VTK. vtk.js uses many of the same basic concepts and base architecture as VTK and provides much of the same functionality. Our next speaker will be Forrest Li, who is a senior research and development engineer on our data and analytics team here at Kitware. Forrest will cover the basics of vtk.js. He'll show you a live demo, and he'll cover some specific case studies that highlight the functionality of this toolkit. We'll wrap up with some discussion of future work that we'll be doing on vtk.js and give you some guidance on how you can take the next step to integrate vtk.js into your project. During the webinar, we will be pausing to answer questions throughout the webinar. So if you have a question, there's a little bubble somewhere on the interface. Looks like a double speech bubble. That's the chat section of GoToWebinar. So if you go in there and type your question, we'll be sure to answer it during the webinar. And definitely at the end, we'll have some time for Q&A. And don't worry about trying to copy down things that you see on these slides. After the webinar, we'll send you a copy of the slides. So what's Kitware? Kitware is a research and development company. We have about 200 employees across our offices that are throughout the US and in Europe. We've been around since 1998. We are committed to open source and open science, and we are proud to be a 100% employee-owned company. We're also a highly collaborative company. We work with many academic, government, and commercial organizations on some very large-scale research efforts. And whenever possible, we like to share the results of that work through our open source platforms like vtk.js. We provide training, support, commercial research and development services related to our platforms and our expertise areas. And our primary focus areas are in healthcare and life sciences, energy and manufacturing, and defense and intelligence. We work on a variety of platforms, from mobile devices to supercomputers on a desktop and in a web browser. As a company, we're known mostly for our open source platforms, and you can see a bunch of the logos there at the bottom of this slide. We build vibrant communities around these platforms, and we keep them going for a long time. VTK, which you'll hear about today, has been in use and used throughout the world, is powering a lot of visualization applications for 30 years now. And at this point, I'm going to pass the presentation over to Sankhesh, but please remember that if you have any questions, please add them to the chat area and we will answer them along the way.
Hello and good afternoon. VTK is a C++ software library that provides an object-oriented approach to visualization, which means it provides the basic building blocks for visualization. Now, visualization here is not just painting pixels on screen. It is reading data, processing it, and then converting it into interactive, intuitive images on screen that can then be used for inferring a higher level understanding of the original data. While its primary development is in C++, VTK is available across many different software languages, including Python, .NET C#, Java, and JavaScript. On top of this, VTK-based applications work on all your favorite devices and operating systems like Mac OS, desktops, Android phones, or HPC smart supercomputers. VTK is licensed under a permissive open source license, which allows you to download, modify, and redistribute the software at will. The first few lines of VTK code were written back in January 1994, and over these past 3 decades of VTK, it has grown to be a universal toolkit for data visualization across various scientific disciplines. I invite you to read the blog post written by Will Schroeder, one of the original authors of VTK, about how VTK came to be and its success story. A good measure of any open source software success is the community around the software. And as you can see from this bottom graph showing contributors per month, there has been a steady increase in contribution activity to VTK. So how did VTK stick around for 30 years? Well, one attribute is nightly and per merge request testing using CMake and the CTest test suite. This was instrumented way before GitHub Actions and Circle CI, etc. came around. These are unit tests, regression tests, dynamic sanitizer tests, etc. that are run across a variety of Windows, Linux, and Apple machines. Another factor, Kitware is the lead maintainer, but not the enforcer for VTK. We are highly receptive and in fact dependent on community interactions. An example from recent memory, there was a question on what should be the next gen documentation for VTK. There was a discourse post with all the different options presented, and based on the polls and discussions on the post, it was decided that Doxygen would remain the developer's documentation, but we would move to read the docs to provide user level documentation. So that's the kind of community involvement that keeps VTK thriving. When looking at VTK, there are two basic principles of design. As I mentioned earlier, VTK just provides the basic building blocks that can be modified and assembled based on individual application requirements. These building blocks are split up into individual modules. The basic idea is that each module provides a specific functionality. It does one thing well. The second design principle is the visualization pipeline, where data flows from one node to another in a pipeline. With these powerful concepts, VTK can be used to process data and create intuitive imagery, interact, and visually search through your data, and all while remaining performant even when dealing with large data sets through parallel processing and parallel rendering techniques. So what can VTK be used for? Well, use it to show some text on screen, do some 2D charting or plotting of your data. And where VTK really shines is interactively processing and rendering 3D and 3D plus time, which is 4D data. And data could be polygonal mesh data like CAD geometries, or volumetric data like CT or MRI scans. On the application side, VTK can be integrated with various UI toolkits across different platforms. And it also provides something called interactive widgets, which allow you to manipulate the rendering on screen and provide feedback to the VTK pipeline. Speaking of pipeline, here's a gist of what a pipeline looks like in most cases. You get data, whether be it from disk or acquired directly from a sensor, pass it through a series of transformations that massage it into a different resulting representation that is then delivered as a rendering on screen or written out to disk or sent to a consumer process. All the while, downstream objects can provide feedback to manipulate the upstream processing. Here's an example of one such pipeline where some data that can come from in over 100 different file formats is sliced using an interactive plane widget manipulated by the user in real time. At this point, I'll pass the presentation over to Forrest, who will go over how these powerful concepts of VTK have been translated into vtk.js. And while I do that, please remember to type your questions in the chat window.
Thanks, Sankhesh. So vtk.js is not too much different than what you just heard about VTK. So vtk.js is, in fact, a rewrite of VTK for web browsers. It is a cross-browser JavaScript library that relies on WebGL to generate interactive 3D visualizations. It is the same architecture as VTK C++, so everything just discussed and any VTK knowledge that you may already have already translates over to VTK.js. So you don't have to learn really too much of anything new other than getting used to web technologies. And since VTK.js targets a broad range of WebGL-enabled devices, it focuses on giving performant and interactive visualizations. So it targets from desktop, mobile, and everything in between. Additionally, its flexible architecture allows for easy integration into existing applications if you need to bring in specific 3D visualizations into your applications or product. So why consider vtk.js? Well, there are kind of two facets that you can look at this from a strategic and from a technical perspective. So vtk.js, like VTK itself, is licensed under the permissive BSD3 clause license. So this means that you can modify, distribute, sublicense, and use vtk.js across personal and commercial projects freely. It is also open source and freely available, and we make this project freely available in part to foster interest in web-based visualization technology, but also to let those who have existing VTK knowledge bring their visualizations to the web, and as well as encourage the community to engage in the project. And of course, you can bring your years of existing VTK knowledge to vtk.js, and most things just work. Like I said before, it also targets a broad range of devices from desktops to mobile devices, basically any device that allows you to run a web browser and has some semblance of a GPU will be able to run vtk.js. And so it allows for a broad range of distribution, because all you have to really do is send somebody either an HTML file with vtk.js embedded or point them to a website, and they'll be able to visit it and be able to visualize whatever data that you have made available there. Additionally, it is supported by Kitware as well as the community around vtk.js and VTK. So there are a lot of tutorials, a lot of material documentation that exists around there in order to help you on your project and your usage of vtk.js. On the technical side, vtk.js is very easily integrated. You can progressively integrate it, and I'll talk a little more about this, but whether you are starting your application at an early stage or you already have a mature application that you simply need integration with, vtk.js can be brought in at any stage of the project lifecycle in order to provide you with the 3D visualizations that you are looking for. And this is achieved through its modular architecture, which allows it to be very flexible in how you choose to consume it and how you choose to integrate it. Additionally, there's a focus on interactivity and performance. Since vtk.js may have to run across a wide range of devices with varying hardware, it tries its best to remain performant in all such cases. It also has integration with other libraries for in-browser data analysis. So for instance, ITK-WASM, for those of you who are not familiar, ITK is the Insight toolkit, which is a powerful image processing library for medical imaging and beyond. And it plays very well, vtk.js plays very well with ITK-WASM in integrating so that you can do data processing and then convert those into vtk.js native data types for visualization. And finally, vtk.js focuses on advanced geometry and 3D volume visualization. And so there's a lot of flexibility in how you can choose to visualize it, whether it's through color maps, whether it's through certain kinds of geometry, whether you need to look at slices of an image or the whole volume. There's a lot of different options that you can have to visualize your data. So from an integration standpoint, it's pretty straightforward. For those of you who are familiar with web application development, it is consumable via standard packaging sources. So you can pull it from NPM, you can pull it from unpackage, or you can build it yourself and integrate it into your application that way. It is ESM native, so that means that it supports the current standard of JavaScript modules. And so you can easily integrate it into any modern application that relies on that. Additionally, vtk.js is framework agnostic. It doesn't necessarily have any particular ties to a framework like React or Vue or Svelte or any other ones that you have. However, we do provide some nice layers for React through the React vtk.js project, as well as Vue through the Vue vtk.js project. And so how you choose to integrate vtk.js is really up to you. You can do something as simple as having a embedded view inside your web application or even web page that demonstrates some sort of visualization that you want to show. Or this can go all the way to developing a full-scale application around using vtk.js, as is shown in this screenshot of Glance, which I will be demoing shortly. So vtk.js really can kind of it can be brought in anywhere in between these two endpoints on the continuum, and it's generally very flexible in how you want to consume it. With that, I would like to go and do some demos. So like you saw before, there was a little screenshot of Glance, and so what we'll do is we'll take a look at this application. So Glance is a general 3D data visualizer based off of vtk.js, and it supports a variety of different volume formats, geometry formats, so STLs, OBJs, all the way to NURDs and nifties for images. It is open source and freely available, and everything runs client side. So all the data that you open through here never leaves your machine. And additionally, this has been used for embedding into existing web applications and web pages, and I will discuss that a little more in just a bit. And just as a general note, there may be lag and bitrate problems with sharing this, so any lag that you see on this presentation really is probably just due to bitrate issues and just general network lag. So let's take a look at this. So this data set is being pulled from a public data source, and this is a mixing vane inside a reactor pin used for cooling. And so this is geometry data set that is from a project called Hydra TH, which is a simulation package used for thermal hydraulic simulation. And so this demonstrates visualizing streamlines and geometry, and as well as some of the coloring capabilities of attributes associated with the data set. So for instance, if we take a look over to the left here, we can, of course, adjust the coloring however we'd like. Here I just changed the coloring. And so Glance here is able to pick up on this data set having attribute values associated with each point. And so, for instance, we could color this a solid color, but that doesn't give us really much information. As you can see here, there is a single scalar value, a scalar data, essentially an array of data associated per point, and we can color by it and be able to visually see the values as colors along this color transfer function. So like, for instance, if we take a look at the points, for instance, we'll increase the point size so it's a bit more obvious. But you can see here that each point has its own distinct value and therefore a color. So this is just one sample of taking a look at the geometry capabilities of vtk.js. Another thing we can take a look at would be some images. And so this is a lung CT scan, I believe, of a coronavirus patient. So this is a data set indicating where there was issues with the patient showing these ground glass opacities that indicate that there is, the viral infection inside the lung. And so this just demonstrates viewing 3D volumes. So this is a 3D volume, and you can kind of take a look from the 3D view here, where we can visualize the volume. It's a section of the chest scan, primarily focused around the lungs. And so I'm not going to get too much into looking at this data set because Glance primarily excels at general 3D visualization and not necessarily medical, but I will be demoing another application after this that shows off vtk.js in a medical specific application. But you can adjust the slices to view different parts of the volume, and of course you can adjust the color map as necessary, though in this case there's really not much that you can change it to. But for instance, if you want to take a look more around the bones. The next sample that I want to show is actually using Glance to download remote data sets. So in this URL example, we can pull data from a public network source and have that load and be visualized right within Glance. And so in this case, this is not like a case of your data stays local to your machine, but this is, we can download data from arbitrary data sources and then show them. And so this data set is from the steps library, which is the stochastic engine for pathway simulation. It is an open source stochastic simulation package just for any sort of stochastic based simulation. So in this case, what I have pulled is a data set that it is a 3D chemical oscillator simulation. And so what this actually allows us to do is, it's a simulation. So clearly we should be able to see something. And so we can demonstrate that we can run through the simulation. And this is not running it through it live, but this is showing off that vtk.js can in fact take time series data sets and render them. And you can of course control it and view different parts of it. So if I wanted to go and pick an intermediate stage and then step through, and we can see that we can essentially see this simulation results at any step of the period of capture. And of course, we can color it based off of different attribute values. So this would be the X concentration, this would be the Y concentration, and there are various other different properties that you can color by. But for this simulation in particular, the Y concentration is the most relevant attribute. And so Glance generally also has other features. You can export state. You can actually use peer review to export into Glance. You can capture screenshots. All of these are generally enabled by vtk.js. Next up, I would like to show off a more medically oriented application. So this is VolView, and this is, again, like Glance, it is open source. It is freely available. This example is also readily accessible over the internet. It is also all client-side, so any data that you choose to load will never leave your machine. It'll all the rendering, all the processing, all the reading all happens on your machine and in the browser. And like Glance, it can also load data sets through the URL, but I'm not going to demonstrate that today. So we'll load one of the sample data sets from the side. And so this is a CT scan of the head and neck. And the view that you currently see here is a lot more medically oriented application using vtk.js. So this is more of a standard radiological interface with customizable visualization options as well as tooling. So this is more kind of what a radiologist might choose to expect instead of using Glance. And so off the bat, we have window level controls. vtk.js allows us to be very flexible on how we choose to color our two-dimensional slices and how we choose to render the two-dimensional slices. We have standard controls where we can choose to pan, we can zoom, we can additionally use crosshairs to synchronize the slices across all three axial, sagittal, and coronal slices. And so additionally, we have a set of tools. And so vtk.js also is heavily focused on having interactive tooling in order to be able to not just look at your visualization, but also interact with them. So for medical applications, one thing you might choose to do is annotate, or in this case, paint. And so, for instance, I can adjust and do some painting here. So we can label some vertebrae. Right now, this is not labeled for vertebrae, but we can, we can just call that bone. And of course, we can choose different segments. And so this is all rendered using vtk.js. This is simply just another image layer on top that allows you to draw. And so, I can continue doing some level of annotation. Additionally, we also have support for various polygonal tools. So for instance, I can draw rectangles. I can also draw polygons. And we can adjust those polygons as necessary. We can deselect that, as well as rulers. So for instance, if I wanted to measure various parts of it, and of course, right now I'm coloring white, so that's probably not the most visible, but we can switch over to red and measure various parts of the view that you currently have. And so this is all using picking routines in vtk.js to be able to know where you're clicking on in the 3D view and place down the markers. Finally, just another thing about the coloring is we can also just apply various presets to the to the 2D visualizations. Finally, we have the 3D visualization. And so in this case, what we actually are showing here is a cinematic volume rendering of the volume. And so vtk.js does have support for cinematic volume rendering. And what that means is the 3D view, the 3D visualization is a lot more quote unquote realistic. It is meant to be a lot more interesting of a visualization rather than kind of like a plain 3D visualization where the color transfer functions might not necessarily look like really nice. But in this case, we can control various aspects of this rendering. So if I wanted to switch over to X-ray, we can get an X-ray view of the data set. There are other various color transfer functions for various purposes. And then here are the cinematic rendering controls. We can slightly improve the rendering, and this would be useful generally for like if you wanted to take a screenshot and use that inside of a publication or a blog post or some sort of other public presentation. And then finally, there's actually support for cropping. And so, for instance, if you want, let me turn this down so that we can actually see this better. So cropping might be actually not working right now, but you will be able to crop the 3D volume and show different parts of the volume inside the data set that you're looking at. And so all in all, this is a demonstration of vtk.js used in a very specific domain. In particular, this is the medical domain, and how it can be pretty flexible in allowing you to visualize your data sets in a very medically oriented manner. So there are other couple of examples that we can briefly take a look at. So vtk.js does provide a set of live examples that are online and available for everybody to kind of look at and play through. And so, for instance, we can take a look at the contour loop extraction example, and this is an example demonstrating how you can take geometry and cut it along a particular plane. So in this case, we have this like plane going along through the like snout, mouth, and then through the body of this dragon, and be able to extract the loops out of it. So for instance, here we have 4 loops. We've got one of the lower body, neck, the lower jaw, and then over around the nose. And so this is demonstration of how vtk.js can also be used for various data processing and pipelines, so that you can, if you need to slice along your data set, this is one example of how you can do that. Other examples include, let's see. So this is a really basic example of computing intersections with an OPB tree. And so, for instance, here you can see, this is not an interactive example, but you can see here that we can compute the intersections of these 2 arrows, and the kind of border of that intersection is demarcated with cylinders. Other examples of data processing, we can do smoothing on geometry. So for instance, here we can take this cow model and smooth it. And then from an interactivity standpoint, we can also add widgets into the scene. And so, for instance, here we have the ability to draw splines. So for instance, here I'm going to start drawing a spline, which allows us to kind of fill a region and generally interact with our data sets and visualizations in a lot more of a meaningful manner. And so there I was able to use the spline widget in order to draw out the outline of where I wanted to apply some paint. And so there are
here. I just want to ask some of the questions that have come up.
Yeah,
we have one that asks if the cinematic rendering uses a specific renderer. Is it Osprey?
It does not use any specific renderer. Everything is done in WebGL on the browser. And so it is, I'm just going to call it a custom cinematic volume rendering implementation. It is very similar to the one used in vtk.js, but I'm not the best person to talk about that.
And then we also have a question on whether the annotations or geometry applications in VolView applied to a particular slice. Do they disappear if we change focus?
Yes, they do. Yeah, so I didn't demonstrate that, but yeah, all those annotations do stick to a particular slice. They are annotated on a single plane and a single view.
And then finally, what is the tech stack that's used for Glance?
So that is a Vue.js application built using Webpack, and the UI framework is Vuetify. It is very similar to the tech stack used for VolView, but I've worked on code bases where we've used vtk.js and React, even in Angular.
And then another one, Kitware documentation of vtk.js says that vtk.js is a complete rewrite of vtk C++ using plain JavaScript. The documentation also says we are not aiming for vtk.js to provide the same set of filters that is available in vtk C++. Which statement is true? What are the limitations of using vtk.js when compared with vtk C++?
Yeah, so it is not a complete rewrite. It is a rewrite for sure, but there are a lot of missing features. You know, a lot of the filters and stuff simply don't exist in vtk.js compared to vtk C++. And Sankhesh can also speak to that as well if you would like.
Yeah, I would preface it by saying that that documentation, that line of documentation, I know exactly where it comes from. It was actually written as one of the first few commits of vtk.js, where the original goal of writing vtk.js was just to provide rendering features. So the idea was somebody would do rendering, or actually they would have a whole pipeline written out in C++ or some desktop application. They would do their processing, and then finally, when it comes time to render, they would then hand it to vtk.js so that you have your rendering in the browser. Since then, things have changed and things have evolved for the better. We do have some ability of processing, as Forrest has demonstrated. We have some of the filters written out. We have some I/O capabilities where you can write out a whole scene from a post-processing application, like say ParaView, that can then be loaded into vtk.js. So things have matured quite a bit since that writing.
Yeah, and then just to speak to the limitations question, so there's a lot of limitations imposed directly by the browser. So for instance, loading very, very large data sets will be roughly the same as if you try to load very large data sets on your machine. Of course, there's a lot more of a memory constraint. Browsers tend to constrain memory a lot more than the operating system. And additionally, There's limited, but there is some support, but limited parallelizable processing capabilities in vtk.js. All right, any other questions? If not, I will continue on. All right, so yeah, just to wrap up, there are a lot of different examples that you can play with, and this is on the vtk.js documentation website, which I will link to. There will be a link in the slides at the end, so if you want to wait for that, you can. All right, just a couple of case studies using vtk.js. So vtk.js has been used to visualize results of machine learning outputs. So in this case, this is a TensorBoard plugin that allows you to take results of medical imaging deep learning output and visualize them with all the kind of goodies and allow you to adjust your visualization options. So in this little animation, you can kind of get a sense of the options that some of the options that you have in order to take a look at. In this case, this is, I believe, I don't know the anatomy, but it's probably like the liver segmentation, and so this is just looking at the label map. And so this is generally really useful because for 3D volume machine learning, in this case in the medical field, usually you end up having to look at 2D slices, so you don't get kind of like a holistic view of your data set. And so being able to see the output results in 3D gives you a lot better sense of the structure of the segmentation that your deep learning algorithm has produced. And so there are a plethora of tools that you are given in order to adjust the visualizations. And so some of these are very similar to the controls that I demoed in VolView. Additionally, vtk.js has been used for visualizing simulation results, like I demoed with Glance. In this case, this is a company called Quansient. They are a company that specializes in cloud-based simulation software. So users can log in, they can submit their multi-physics simulation to Quansient's cloud computing platform, and then let that job run. And then when it's complete, they can come back on any sort of machine. All they need is a browser, and they can come back and visualize the results. And this is not just the read-only visualization. You can use picking to select regions for further analysis. You can toggle layers. And additionally, this actually hooks into a pair view backend to enable further advanced data processing. So there's a lot of warp operations supported, there's clipping and there's slicing and a lot more. And so for those who are not familiar, pair view is another open source post-processing visualization engine. It's built on VTK, and it primarily is targeted towards like large data processing as well as supercomputing.
So Forrest, back on the VTK plus machine learning slide, we have a question asking if there's a URL that we can provide that gets to that.
Yes, I can provide this at the end of this. If you do want to look it up on your own, this is called TensorBoard 3D.
Yeah,
So
perhaps we could add the link to the slide, so it'll be there when we send it out.
Yeah, we'll add links to the slides. All right, and then another one is the vtk.js has been used for medical image quality assurance. So this is a project actually aptly named MICA, so medical image quality assurance. And so this is primarily using vtk.js just for the 2D views, for the axial, sagittal, and coronal views. It is a very familiar interface for medical imaging researchers who are familiar with 3D Slicer, and it is and in this case, vtk.js is used to help visualize data sets and have QA folk to kind of go in, take a look quickly, and then annotate as necessary and mark whether the data is unusable, whether it is usable, or any other kind of states that you need there. Finally, vtk.js has been used in 3D modeling. In this case, it's been used part of Castle for I think they are a DOE group, and this is for rendering simulation results and models of light water reactors. And so this is just kind of showing off how they're able to use vtk.js to visualize large complex models of various parts of the reactor, as well as supporting toggling of various parts of the model on and off, and make this into a web application that allows many other people to use it across the board without having to wait for software to download, and also allows them to push out updates fairly quickly without having to have people left behind update wise. All right, so just briefly, I wanted to talk about the future of vtk.js. So vtk.js, of course, like I said, we use WebGL for the rendering backend, but we do have an initial WebGPU implementation as well. So WebGPU is the successor to WebGL. It provides much better performance because it's a lot closer to the GPU than WebGL is, and also enables really cool things such as custom GPU shaders that allow you to run compute rather than just rendering. And so you don't have to deal with trying to do like threads, or don't have to try to deal with like hacky WebGL based compute. You can actually just write WebGPU compute shaders and leverage the GPU that way. Additionally, we also have a WASM build of VTK. So those of you who don't know, WebAssembly or WASM allows us to take C++ or kind of any other like bare metal targeted application and bundle it targeting WebAssembly and have that run in the browser. And so, this is kind of like one of our longstanding answers to the question of, so vtk.js doesn't support all the filters that VTK does. So how can we leverage that? And one answer is we can combine vtk.js with VTK WASM. This is an ongoing thing, but that will eventually allow you to leverage the power of VTK in the web as well. And so sooner or later, this will become like a synonymous thing. Additionally, maybe you don't necessarily need to have vtk.js render really large data sets. I mean, generally speaking, what that's going to happen is you might crash somebody's browser, or it'll just take forever to load. And there's a lot of different reasons why you might not want to render things completely client-side. And so there currently are several different solutions for doing hybrid and server-side rendering. So generally speaking, what this gets you is we can avoid rendering large data sets. We can avoid downloading large data sets. Additionally, if you don't want to send data sets over to the client because you feel uncomfortable with doing so, well, you can avoid that entirely if you do server-side rendering, or if you do downsampling in a manner that doesn't necessarily mean that you're just like giving clients your data. One project that we'd like to call out is Tram, and so this allows you to use vtk.js with server-side rendering, and it does a lot more than just that. I'm not going to say too much about it, so be sure to catch the webinar, which happens, I believe, roughly in 1 month from now, There's a link to the webinar here, and it will talk all about Tram and how you can use it to build your applications in Python, your web applications in Python, leveraging vtk.js and a lot of really cool Python stuff. So just to wrap up, there's a lot of different ways you can get started using vtk.js. We have the vtk.js documentation that includes links to all the examples. There's the GitHub repository that contains vtk.js if you want to start contributing, if you want to check it out, build it, try it out yourself, or integrate it into your application. If you need any help with it, you can always ask us either on the Kitware on the vtk.js discourse or on the vtk.js repository issue tracker. And if you need more support than just that, we do offer paid support, so you can contact us for any sort of support that you need on your vtk.js applications. Furthermore, we can also engage in a lot more complex partnerships. So we can do a lot of software customization. For instance, we can take Glance, we can take VolView, and we can customize it to your specific application. We can also do branded applications. And we also really do like to do collaborative research. So if you have any sort of grant-based projects that you're interested in starting, we also can be co-PIs or subcontractors on such opportunities. So if you want to reach out, feel free to. We have our contact info here at this URL. And thank you all for attending this webinar.
Yeah, we have one more question that came in. In some examples, the picking works with a right click. Would this work on tablets and smartphones as well? And how would the right click be substituted?
Yes, so that's the fun one. Right clicks on tablets and other kind of touch-based systems will highly depend on also the operating system it runs. So for instance, like Windows tablets, you hold your touch in order to trigger a right click. On other platforms, I'm not familiar with it. So generally speaking, if you are targeting mobile devices, that becomes a UX question. How do you want to allow users to engage with this concept of a right click? There's no good answer to it. That is a broader question, more beyond what vtk.js can like say. But you can adjust your expectations, and like if you want to do a hold-based right-click detection, vtk.js can also do that.
Sankhesh, you wanted to add something?
Yeah, just because that example chose right click to be used for picking doesn't mean that that's what you have to stick with. vtk.js is highly customizable. You can choose whatever you'd like for your application to be the picking mechanism.
Yeah, all the interactions are not necessarily set in stone. You can remap the interactions to whatever interactivity you would like.
Great. Any other final questions? We do want to thank you all for joining us today. As I said, we will send out a copy of the slides and a link to the video from this webinar if you want to review it again to get back and look at something. Feel free to reach out to us if you have any questions that come up afterwards or want to discuss vtk.js in more detail. We'd be happy to set up a meeting. So thank you all for attending and have a great day.